Thanks, Dane. Welcome, everybody. My name's Joe Tremaine, and I'd like to thank you guys for joining us, taking time out of your days, and with everything crazy going on. We appreciate you guys taking some time to learn a little bit about the integration technologies. Like I said, this is the April Applications Engineering Live webinar about introduction to the integration series, Integrations Technologies Explained. I'll be explaining about the various forms of technologies that we encounter in our daily lives. Again, my name is Joey Tremaine, and I'm an applications engineer at Springs Window Fashions, located in Middleton, Wisconsin. So thank you for taking the time to attend this webinar. All right. In today's webinar, I'll be discussing the various forms of integration technologies that you see today. I will be characteristics of each form, the technologies, and what types of applications you may likely find with these technologies being utilized. And finally, I will be going over some of the interesting facts about technology that you may not be aware of. During this webinar, I will also be having a pop quiz. So make sure that you have a writing utensil and a spare piece of paper to write your answers on. So the first section that we will be covering is the various forms of integration technologies. Z-Wave key facts. The Z-Wave protocol is an interoperable wireless RF-based communication technology designed specifically for control, monitoring, and status reading applications in residential and light commercial environments. It also operates in a sub-1 gigahertz band, impervious to interference with the Wi-Fi or other wireless technologies in the 2.4 gigahertz range. That includes technologies like Bluetooth and Zigbee. The last key component of the Z-Wave technologies is it offers full interoperability through layer 6 and backwards compatibility to its previous versions. So if you upgrade on Z-Wave, you can always go back to older versions because it can read it without any problem. For Zigbee, this technology was also specifically built for control and sensor networks on an IEEE 802.15.4 standard for wireless personal area networks. And it's also a product of the Zigbee Alliance. It's also known to be a low-cost and low-powered mesh network widely deployed for controlling and monitoring applications where it covers 10 to 100 meters within the range. The communication system is less expensive, and some may say that it's easier network versus other proprietary short-range wireless sensor networks as Bluetooth and Wi-Fi. Zigbee systems structure consists of 3 different types of devices, such as Zigbee coordinator, a router, and end device. Each Zigbee network must consist of at least one coordinator, which acts as a root and bridge of the network. The coordinator is responsible for handling and storing the information while performing and receiving the transmitting data operations. Zigbee routers act as an intermediary device and permits data to pass to and from them, through them to other devices. End devices have limited functionality to communicate with the parent nodes. Each integration technology key points I'm going to touch now the next integration technology key points that I'm going to touch on now is, we've all heard it before, is TCP/IP. TCP/IP is abbreviation, stands for Transmission Control Protocol, Internet Control Protocol. Transmission Control Protocol is a standard that defines how to establish and maintain a network conversation through which application programs can exchange data. TCP works with the Internet Control Protocol, IP, which defines how the computers can send packets to data to each other. The TCP/IP technology was developed in 1960s, where it allowed digital computers to communicate over long distances to each other. The last key feature that we're going to talk about on this feature is the TCP/IP Open Protocol Standard. It makes it freely available technology and developed independently from any specific computer hardware or operating system. Because it's so widely supported, TCP/IP is ideal for uniting different hardware types and software components. This technology can be run over a DSL, cable, internet, dial-up, or even optical fiber lines. You can even use TCP/IP technology if you don't communicate over the internet. Now we'll discuss the key points I'd like for the dry contact technology. First, it's called volt-free contact, which is a relay contact that does not supply voltage. The relay is not wetted by a voltage source, giving it the same, the same dry contact. The relay energizes or de-energizes when a charge comes to it has occurred. In other words, a dry contact simply detects whether an input switch is open or closed. Another key feature about the dry contact technology is because you define what the open and closed conditions mean, dry contacts are infinitely adaptable, meaning basically that because you can adjust a circuit from one state to another, from open to closed, it allows you to use the technology in so many different avenues. The last key feature is, I'd like for you to know, is that dry contact can be powered from any voltage from 120 back to 277 back. For RS-232 technology, the first thing I'd like to go over is the technology offers both synchronous and asynchronous protocols. Synchronous communication requires the sender and receiver to share the same clock. The sender provides a timing signal to the receiver, so the receiver knows when to read the data. Synchronous communication generally has a higher data rate and greater error checking capability. A printer is a form of synchronous communication. Asynchronous communication has no timing signal or clock. Instead, it has a start-stop bits into each byte and data to synchronize the communication. It also uses less wire for communication with no clock signals. Asynchronous communication is simpler and more cost-effective. RS-232, RS-485, RS-422, and TTL are the forms of asynchronous communication. It also communicates at speeds of from 100 to 220K baud. And the next key component that RS-232 offers is a variety of different communication protocols. It communicates over binary, hex, des, oct, and ASCII, allowing more versatility communication between the devices, not limiting it to one standard protocol. The RS-232 technology only will transmit data up to 50 feet, which of course drastically limits communication to small offices, data rooms, and home office environments. This technology could be utilized. And finally, the last key component I'm going to discuss is the intended use for RS-232 is that it's a standard protocol used for serial communications. It's used for connecting computers and its peripheral devices to allow serial data exchange between them. As it obtains the voltage for the path used, the data exchange between the devices. Now we're going to cover RS-485 technology. The next, with this, you may hear around Springs Window Fashion's RS-485, specifically more in the applications engineering. We support, RS-485 supports inexpensive local area networks and multi-drop communication links using the same differential signal over twisted pair as RS-422 standard. Master-slave arrangements, some features that are available with this technology is full duplex operation, converters, repeaters, star topologies, applications, protocols, and signals may be used over this technology. After RS-485 technology was approved by the Telecommunications Industry Association and the Electric Industry Alliance, also known as TIA-EIA, as a standard way this cable was going to be created, keeping things consistent across the board. It now allowed for industrial environments to easily and cost-effectively implement this technology in their offices and factories, yet improving the variety of data that could be now transmitted over this network. The final feature I would like to share with you for RS-485 technology is that now using category 5 or 6 twisted pair Ethernet cable, whereas in the RS-232, you were limited to only 50 feet for data communication. You now have with RS-485 technology, you now have the ability to communicate over 4,000 feet from one computer to another signal cable. And the final form of technology integration I'll be sharing with you is the BACnet technology. BACnet also defines as a dial-up or point-to-point protocol called PTP over the phone lines or hardwired EIA 232 connections. The key feature for this technology is that BACnet messages can, in principle, be transported by any network technology. BACnet objects are concepts that allow the communication and organization of data related to inputs and outputs, software and calculations to all be performed. The BACnet object can manifest itself in a variety of ways. With this ability to manifest itself into a variety of different technology communications, it now can communicate to any device out of the network. Finally, BACnet was designed to allow communication of building automation and control systems for applications such as heating, ventilation, and air conditioning controls, HVAC, lighting controls, access controls, and fire detection systems in their associated equipment to communicate with centrally located server that accepts a code to translate its code so that other devices connected to this server can understand the signaling coming from the device connected to the system. And now I've got a time for a pop quiz. Just to make sure that we're keeping our brains alert, I have a quick pop quiz for you all over the technologies that we've just reviewed here. RS-232 technology offers both synchronous and asynchronous protocols. Synchronous communication requires the sender and the receiver to share the same what. And the option or the choices are A, the start stop commands in the data packets. B, the coordinator, router, and end device. C, the clock. Or D, Uncle Ned. So please make your choice for either A, B, C, or D.
You can go ahead and put those choices in the chat box. I think mine is just Uncle Ned.
Do we have every?
I think you're good to go, Joey.
All right. So the answer is the clock. They share the same clock. The sender provides the timing signal to the receiver, so the receiver knows when to read the data. Synchronous communication generally has higher data rates and greater error checking capability.